Today's lesson is about area and perimeter. So, the area of a square is side square. The area of a triangle is half the base times the height. The area of a rectangle or parallelogram is base times height. Trapezoid we all know as half height times the sum of the bases. Or I could write it as h times b1 plus b2, all divided by 2. You may have learned it that way. Now this is probably the new one to you. So if you had to learn something, this would be it. And that the rhombus is the product of the diagonals divided by 2. And when we think about a rhombus, it has all these little congruent sides. So if we drew in, I really shouldn't use the drawing tool because that's not a true rhombus. So if we drew in the diagonals, do you see how it really kind of divides it up into 1, 2, 3, 4 triangles? And do the formulas look similar? Yeah, they do. So think about that when you deal with the rhombus. Okay, so the first thing we're going to do when you're given a problem like this, we're finding area and perimeter. Our first figure is not even a quadrilateral, it is just an old triangle. So when we think about triangles, we can have a couple kinds. We can have a right triangle to where our base and height are actual legs of the triangle. Or we could have a triangle where we had to find the height. Now the height just has to be perpendicular to a base, so a triangle can have multiple heights. Sometimes we might even think of the height as being outside the triangle, such as here, as long as the height is perpendicular to a base. Okay? So, on this one, please plot those 3 points.
That is not a pretty sight. Triangle.
I was doing like one of like these kind of problems in our class where you find like the perimeter, like the distance between 2 points, and I just used like your Pythagorean.
Oh yeah.
It's so much faster than the distance formula.
Well, that's where the distance formula comes
I
from.
don't know why we just not use that.
I do. That's all I ever use when I actually have a graph. The only time I really use the distance formula is if I don't have a graph. But if I have a graph, I'm always just using Pythagorean theorem. Yes, sir.
Oh, okay. Came back to me. So how much longer are we gonna have to use the graph?
What? Forever.
How much longer are we going to be doing what?
Are we gonna be doing units that use the graph for like the rest of the year, or is it just a temporary thing?
We're going to be graphing rest of the year. So next unit is the conic unit. And so we will graph circles, we will graph parabolas, we will graph the ellipse, and we will graph the hyperbola. And then when we come back from the break, because the last unit is our last unit, we will be doing higher degree polynomial functions. So instead of just graphing parabolas, we'll graph cubics and quartics and quintics. It'll be fun.
I like proofs before because they didn't just graph, but
Yeah. Well, we've been doing a lot of graphs. Graphs don't go away. Graphs are wonderful ways to visualize things, though. All right, so we're supposed to find the area and the perimeter. Now, there's a couple different ways we can find area. We can decide our heights or many different things. But when I look at this, what just kind of stands out to me is that this is a height. And it is perpendicular to this as a base. Do you see it?
yes.
Okay, and I chose those two because they're horizontal and perpendicular. And you can just count. I mean horizontal and vertical. So we can count. So what is this? 1, 2, 3, 4, 5. This has a height of 5. What is the base? 1, 2, 3, 4, 5, 6, 7, 8. This distance is 8. So the height of this triangle is 5. The base, which is that segment AB, is 8. Now, do you know that when we talk about segment AB, and we're talking about the length of it, the way we denote that is just write AB without the line over the top? That means the length of AB. So when we're finding the area of a triangle is 1/2 the base, which we just counted as 8, times the height, which is 5. Half of 40 is 20. The area of this triangle is 20 square units. Yes, sir.
So if it was a triangle where we couldn't just count them, would we just find the midpoint of one of the faces and then the vertex of the thing across from it and do a distance formula?
We would have to find something that was perpendicular to a side. For example, if we had something like this, if this were our triangle, what I would do is I would consider this the base, and I would count down here and make that the height. So you just have to find an altitude somewhere on the triangle, and you always want to go with an easy one. Now, it almost appears that these two are perpendicular, and they are. So let's see how I can figure out that they are. This length is up 1, 2, 3, 4, 5. This is over 1, 2, 3, 4. Do you see that gives me a 4, 5 something triangle? And this is down and over. So it's down 5 and over 4. You know what? I don't think they are perpendicular. No, they're not. They just look perpendicular, but they're not. But it does let me know it has to be an isosceles. ABC is isosceles, isn't it?
Wait, what's the
ABC is that
Because
AC, CB.
these.
Oh, the same.
Now, did I have to draw the triangles that way? No. Let me undo that real quick.
was not perpendicular?
AC and CB.
Yeah. You said it's not perpendicular. You're saying
No,
ABC
it's not a
is-
right. From an angle, this appeared to be perpendicular. It is not.
So you can't.
Okay, so could I have done the triangles this way?
I wouldn't do that.
Yeah, you could do it either way, and we still get the same thing. So this is 4 and this is 4. So to find AC, which is equivalent to BC, it's the square root of 4 squared plus 5 squared.
Is that a distance formula?
That is. Okay, so 16 plus 25 is 41. So AC and BC have a distance of square root of 41. Both. So the perimeter would be this 8. It would be AB plus BC plus CA or AC, yeah. So it would be 8 plus square root of 41 plus square root of 41, which simplifies to 8 plus 2 roots of 41. And that would be just units. No longer square because it's perimeter, not area.
Can we do
You did 241.
Instead. Can we do it decimal?
No! Exact, please.
So when you add radicals, you just put the 2 in front of them.
Yeah, because here's 1. This is 1 square root of 41, and another square root of 41 makes 2 square roots of 41.
No way.
All right. Go ahead and draw sketch number 2. It is a rhombus. The directions tell us it is, don't they? And when you draw it, it will appear to be what it is.
Party movers, they ruined it. That's what they did.
They did.
Can't we'll give them that right.
They didn't need to tell us.
If you want a group of rhombus or rhombus. I think it would be rhombus. Because this would be a cactus. You'll say circuses. No circuits. No, that's a different one.
Oh.
Don't die.
Wish I had some water right now.
Do you want some? Actually, no.
Yeah. No pain or anything. It kind of looks like a sideways rhombus a little bit. I mean, it is a rhombus. Tired. Shine.
Okay, so did everybody graph the rhombus? Now, we talked about a shortcut formula for the rhombus is half the product of the diagonals, not diameters. So here's a diagonal. Oh yay, it's vertical. We can count.
5.
And here's another one.
4.
Woohoo! It's a horizontal. We can just count.
4.
4. What is the length of DF? 10. Okay, so the area of this rhombus is 10 times 4 divided by 2. 20. Square units.
That's the area, that's it.
That is. We're done. That's the area.
Wait, is it the multiplying?
Oh.
Yeah, it says
Yeah,
you have
right
to
there.
Find the product that has the product for that.
Useful data.
Right, that's right.
Now, if we wanted to prove this is like really the right thing, do you see how we can see that this is a triangle? And there are 4 of them that are the same. So if we did 4 times the base of 2 times the height of 5 times a half, do we get the same thing? Yeah, we do. 4 times 5, 20. So even if we found one triangle and multiplied it by 4, because there are 4 congruent triangles inside, that's where this formula comes from. Do you get it? Cool. All right, now let's do perimeter. Now, perimeter, we add up all the sides. But what do we know about a rhombus? They're all the same. So I could just do 4 times one side, because they're all the same. And how do I know? By just kind of eyeballing that they're all the same. Up 2, over 5. Over 5, down 2. Down 2, over 5. Over 5, up 2. Weren't all those distances the same? Yeah. So, I need 4 of these. So if this is 2 and this is 5, what is DE? Square root 29. We have a winner. How did she get that so fast? 25. 5 squared is 25. 2 squared is 4. 25 plus 4 is 29. So the perimeter is 4 roots of 29 units.
Good job.
Make sense?
Yes.
All right, you try number 3. And you're welcome. It's an easy square.
So you don't put square units for perimeter, just units.
Correct.
Look at a square. Oh. I need to read the directions a lot more. Honestly, Jordan. I honestly need to read the directions. You know the
Yeah, if it wasn't tilted, it'd be so much. Do I remember the formulas? If you look up.
Just one side square. So what's the draw a triangle like she said?
See what triangles come in at? I'm guessing.
For this thing? Okay, so right two.
I'm doing it. I'm doing it.
The area of this is side square, right? So we found one side is very. I think we found the area. I mean,
Oh, I have a solid area. I did the perimeter first.
We had to feed it.
Route 61, Route
Yeah, we did do the
63, Route 2,
What'd you get for the? What'd you get for basic?
Oh, that's true.
says square all the sides of the same.
No, I'm not saying that's work, I'm saying to don't die.
Why not? Both sides 20, 26, 20, square root of both sides. Okay. So like, if one of these is 20,
Just root
side by side, yeah, okay, root 20, side times side is 20.
Okay. Thank you.
I don't know.
Alright. Let's see how you did. Did you get 8 roots of 5
Yeah.
for the perimeter and 20 square units for the area? Alright, now, I don't know how I did this, but I think I made 1, 2, and 3 have 20 square units for the area. That is not always the answer, by the way. It just happened to be on this one. Okay, so if you counted this, it's 2 and 4, it's 2 and 4, it's 2 and 4, it's 2 and 4. So we knew they would all be the same because it's a square. So 2 squared plus 4 squared is 20. So each side is the square root of 20. So when I square the square root of 20, I just get 20. Even if you squared the simplified version, which is 2 roots of 5. 2 squared is 4, square root of 5 squared is 5, 4 times 5 is 20. Either way you do it, you get 20. Any questions about number 3?
Popcorn and chips.
Alright, number 4 is way more fun. So, let's
Let's do it once.
it is not straightforward. It's a thinker. 1, 2, 3, 4, 5. Wait, 5 negative 1. And then 1, 5. Okay. And then 2, 1.
Is it true?
And then negative 1, negative 2.
Wait, we have one cruel one.
Julian, it's gonna
Wait,
be.
but Julian, that makes it easier. This will be Go bully Julian.
Yeah, it's not bullying.
Alright, you can't really tell by looking at mine,
That's not true.
but it's not just a trapezoid. It's actually an isosceles trap. Because if we look right here, this is over 1, down 1, 2, 1, 2, 3, 4. And this is 1, 4. So AY and CE, AY is equal to CE, E, which is the square root of 1 plus 4, not 4, 4 squared, 1 plus 16, which is the square root of 17, right? So both of those have the same length. So it's not just a trapezoid, it's an isosceles trap. Okay,
That's 2 of the sides.
that might be handy in a minute. Okay. Alright, so now you want to just go with perimeter since we're there? Sure. Okay, so this is up 6 over 6. So AC is a 45, 45, 90 right triangle when I do up 6 over 6. So this would be 6 roots of 2.
Okay.
Let me draw it out for you so you can all see it together. Up 6 over 6. So this would have to be 6 roots of 2. Up 6 over 6. The hypotenuse would have to be 6 roots of 2. Does that make sense?
Yes.
Okay. So what would EY be?
EY would be.
Yes, it would.
I was gonna say 4. I got 4 roots.
Okay, it's down 3 over 3.
It's not down over 4.
No, 3 and 3.
It's, wait.
Okay, so we can do the perimeter now.
Oh, shoot, I keep missing.
It's 6 roots of 2 plus 3 roots of 2 plus 2 of these roots of 17. So it's 9 roots of 2 plus 2 roots of 17.
So we're not gonna find the area.
So now we need the area. So area is 1/2 the height times the sum of the bases. Alright, so we got B1 and B2 dealt with. We know what the bases are, right?
Yes.
So one base is 6 roots of 2, and the other base is 3 roots of 2. So we just need old height. That's what we're missing. Ideas.
Find the midpoint of EY and A and C, and then.
I like it. Find the midpoint of both sides, and then connect it. Very good. So, add them up, divide by 2, add them up, divide by 2. So it looks like the midpoint of AC was pretty easy to do. That midpoint of AC is the point -2. Okay, so now we need the midpoint of EY. So we add them up, divide by 2, and we get 1/2. We add them up, divide by 2,
Okay, that makes sense.
and we get 1/2. It should, thank you.
It was an inside thing.
Okay, so now we have 2 points, and we want to know the distance between those 2 points.
Distance formula.
Yes.
No.
Wait, don't do the distance formula, just plot it, just plot it and then do
Okay.
the CAD.
You're going to do Pythag with decimals? I mean, you could.
I'm sure.
Sure.
And.
This just makes no sense. This makes
More
more
difficult.
sense.
It's like you go half.
Basketball's really complicated.
I'm close. I
If you don't understand the plays, you're screwed. You're on the bench.
Don't do plays, just play.
Okay, so this is -2.5 squared, and this is +2.5 squared.
So it's.
Okay, so that's 6.25 plus 6.25, which is 12.5.
Can this be a decimal?
No.
It has to be a fraction. Square root.
So what are we gonna do?
Can you do the square root of decimal?
Oh,
Can you?
3.5. Can we just find this real rough number right there?
It'd be really ugly.
It's
Oh, well, you
3
do
to
4, yeah, 4 and then like 3 point,
3.5355.
I mean 2 times the square root of 3.125.
So you said put a 4 down here, is that what you're saying?
What?
And 5 times 5?
No.
50?
50?
55 by 4 is. Oh. That's how you got it.
Because then you can have 5 roots of 2 over 2. Joseph,
Yeah,
that was brilliant.
Oh, thank you.
Wait, what did that just happen? Oh, wait, there it is.
Where are we? Are we in that?
This is really rocket science.
I literally don't even know what class I'm in anymore.
Oh, because it's 4
I'm
and
going to,
well,
I go walk outside.
I figured it out, I figured it out.
Okay.
It's like 25, 5, 5, squared root
Honestly,
of 4.
last week was
Yeah,
cool.
no,
Just
it's
email
just
her, just like,
more.
making
Okay,
fast.
Joe,
I'm
I
just
just
gonna get
my
lost. I'm just gonna like.
Sorry, I'm ready.
Alright. Yay, we all figured it out.
We did all that to figure out 5 roots.
Okay, so now we have to do some multiplying. Is there anything I can take half of first? I can take half of 6, right? Can I do it like that? No, I can't do it like that.
Why not?
That's
You do it like that all
illegal.
the time.
If there's one of these on the test, I'm just gonna get up and walk out.
Okay, this has to be 9 roots of 2. Now I can take half of it, but I can't.
I'm gonna turn it, just gonna walk
So
out.
this is all I can
They
do.
ain't grabbing any of my stuff. I'm just gonna
So
walk.
it
Read it, I can just see
is 45 in the numerator. Ooh, root 2 times root 2 is 2 over 2 times 2. Now I can do it. So it's 45 halves.
Wait, what did that?
What?
22.5 square units.
I
2 seconds.
Oh, Miss Willoughby, what is happening?
She had to teach